Hello student, very good morning to all of you. I hope you all are healthy, happy and fine at home. So what did we discuss yesterday? We discussed about the nucleophiles and the living groups, and what is the major difference between nucleophile and the bases on the basis of basicity as well as nucleophilicity. They mainly differ from each other, so that we already learned. Then another thing we have seen, the mechanism of substitution reaction. There are the three possibilities of there we have seen, and some of the possibilities, out of that three possibility, one possibility is ruled out or cancelled or rejected. Why? Because carbon never shows the 5 bond, and that's why the first possibility, a nucleophile attack and form as an intermediate, that type of the intermediate is not possible at all. So, and second path means first one is a departure of the living group. When the living group departs, taking its bonding pair along with itself, and therefore the carbon is an electron deficient in nature, carrying as a positive charge, and that intermediate is known as a short-lived intermediate. Lot of intermediate that is formed, that is called as a carbonium or carbocation. Another when it forms as a carbocation, that molecule becomes as a planar, and there is a possibility of attack of nucleophile equal the nucleophile attack from front side as well as it can attack from the back side. So that type of the possibility may be there, so that we will in detail we will see. But this type of the mechanism is quite possible because that carbocation is formed when a solvent is present over there. If solvent is not there, such type of the intermediate may not be occur. So, and therefore this type of the mechanism is termed as Sn1 mechanism. And third possibility we have seen. Third possibility means what? Attack of nucleophile. At the same time, there is a departure of nucleophile. Therefore, these bond making and bond breaking takes place simultaneously. That type of the process is called as a concerted process. Concerted process means both the things are happening together. And now when this mechanism is happening, we have seen as a general the two things are happening, that CBr bond breaking, and second one is a COH bond is forming. When this type of the things are happening, three questions are arises. That three question, when and how CBr bond break means means breaking of the CBr bond. Second one, when and how COH bond form means formation of the COH bond. And third one, what are the energy changes associated for this conversion. So this type of the thing we have seen. So that concerted process, the third possibility, that is a Sn2 mechanism. So these, out of that three possibilities, two possibilities are there feasible. So for second, the path second and third are feasible, and so that we are going to learn that mechanism only. What is those mechanism? That is a Sn1 mechanism and the Sn2. Path 2 is called as Sn1 mechanism, and path 3 is termed as Sn2 mechanism. So first of all, let us start with the first one, the Sn2 reaction or kinetics and the mechanism. Under this heading, we are going to study this this Sn2 reaction. First question, what is Sn2 reaction? Discuss with suitable example. Or what is Sn2 reaction? Explain the Sn2 reaction with energy profile diagram. Or what is Sn2 reaction? Discuss the or give the evidences for existence of inversion of configuration. Or the question may arise like this, what is Sn2 reaction? What is Sn2 reaction? Explain with the following points. Number 1, that is a kinetic. Number 2, mechanism, proposed mechanism. Third one may be as a nucleophilic attack or nucleophile attack. So that type of the question may appear in the exam. It is very important as far as a exam point of view is concerned, and therefore you must listen this lecture carefully. Try to understand what is, because this Sn1 mechanism and Sn2 mechanism, or Sn1 reaction and Sn2 reaction, you already learned these reaction in your previous classes in I think in a 12th standard. So here is a extended version, means some extra knowledge you have to acquire this year at TY. So in Sy/Bsc also you might have heard about that one Sn1 and Sn2 reaction. Let us see the extended version of this. What is the Sn2 reaction? What is Sn2 reaction? How would you answer this? Very simple. You just tell the full form of that Sn2. What do you mean by Sn2? Sn2, S stand for substitution. S stand for substitution. N stand for nucleophilic. And 2 stand for bimolecular. 2 for bimolecular reaction. That is the answer of this. Very simple. What is Sn2 reaction? Sn2 reaction means substitution, nucleophilic, bimolecular. That's it. It is so simple. Understood this one? Substitution, nucleophilic, bimolecular reaction. Now this reaction we are going to learn here the first point. What is the first point? Here we are going to learn, or you can call it as a point, or maybe as a 1. Whatever you feel is a easy way, 1, 2, 3, 4, 5 like this, or you can give the points A, B, C. Let us see first one is a kinetics, right? Now is a kinetics. Kinetics. What are the things to talk in the kinetics? And as we know that kinetic is nothing but it depends upon the rate of the reaction. And rate means whether the reaction, following reaction is takes place slowly or moderately or very fast reaction. So that type of the to determine the rate of reaction, that's why it is called as a kinetic. And in the kinetic, how many molecules involved in the actual reaction, and that things are called as a kinetic, right? Now in the kinetic, if you remember as a rate of reaction, let us consider before starting this one, let us see the general reaction of this, the Sn2 reaction. The general reaction, consider the hydrolysis of methyl bromide by aqueous sodium hydroxide to yield methanol. So this is a simplest reaction we are going to see over here. And for Sn2 reaction, always remember the Sn2 reaction occurs in the primary alkyl halide. Remember primary, and as we know that alkyl halide means what? The organic compound having general formula Rx is known as a alkyl halide, where R is a maybe as a alkyl or aryl group. But aliphatic carbon atom, here you just remember that is a saturated alkyl groups are there. Means again alkyl halides are classified into 3 types. Number 1, primary alkyl halide. second one secondary alkyl halide, third one is a tertiary alkyl halides, similar to as alcohol, primary alcohol, secondary alcohol, tertiary alcohol, similar to as amine, primary amine, secondary amine, and the so how do you recognize alkyl halide? Means that suppose as a starting compound R CH2X, means this halide group attached to CH2 group is known as a primary alkyl halide. Now second one, suppose a secondary CH, means here R and X, means this CH2 group, halide group attached to CH, and that carbon attached to further two carbon atom. Here the carbon atom attached to only one carbon atom, and therefore it is known as primary. This is known as a tertiary. And suppose this one R, then you can R X, this group is called as a tertiary. And so tetra halide also there, but here primary, secondary, and the tertiary halide, because when Sn2, we are going to talk about Sn2 mainly, it takes place between the primary halides are. Why that primary halide, why Sn2 reaction occur in the primary halide? The answer of this we will get shortly, or as we are proceeding this chapter point to point, then you can understood why the Sn2 reaction present in the primary halides. So that answer we are going to find out here. But let us see, as a primary alkyl halide, what is the general reaction we have taken here? We have taken as a general reaction is a methyl bromide. Consider the hydrolysis of methyl bromide with aqueous sodium hydroxide to yield methanol, right? So that is the general reaction we have considering here. So the general reaction, this one CH3 Br, and that will be treated with aqueous sodium hydroxide, means here OH minus, here you can write aqueous sodium hydroxide. Again remember, aqueous sodium hydroxide means what does it mean? Aqueous indicate as a water, right? The sodium hydroxide pellet or powder dissolve in water, whatever solution is formed or obtained is known as a aqueous. So now what do you get here? You are going to get the product or yield is a OH, and plus Br minus is a leaving group here, right? So this is a substrate, as we know that substrate, or it is known as a methyl bromide. OH minus, it is a nucleophile over here, nucleophile, and this the product form is known as a methanol over here, methanol, and this is a leaving group. This is a leaving group. If you observe this reaction carefully, what do you see here? The substrate is a methyl bromide, nucleophile is a OH minus hydroxyl group, and here the product form, that is the methanol and the Br. Now we are going to study this reaction, and this reaction is studied by one scientist, and he has given the experimental proof as well as theoretical proof. Ingod is a scientist name. He studied this experiment and very precisely and given the data regarding that Sn2 reaction. Now what is the first point we are going to learn here? First point is a kinetics, right? Kinetics we are going to study. Kinetic means we are going to find out a rate of reaction, whether the reaction is a faster or a slower, or that type of the kinetic we are going to study here. If you observe this reaction carefully, the nucleophile is attacking to that carbon atom, and there is a departure of leaving group. Incoming group is a nucleophilic negatively charged, outgoing also as a negatively charged, means strong nucleophile replaces the weak nucleophile, and this type of the reaction is called as a nucleophilic substitution reaction. And this nucleophilic substitution reaction, whether it is a unimolecular reaction or the bimolecular reaction, how do you find it? How many molecules are involved in this reaction? And here the molecule CH-3 Br and OH minus, when they get reacted to each other, what they found, Ingold is a scientist name, he studied this experiment very precisely, and he has given he found that rate of reaction is directly proportional to the concentration of the substrate as well as nucleophile. Look at what he said, that the rate of reaction is depend upon the concentration of the substrate, and therefore what he find, rate is equal to concentration of substrate, means here we are using methyl bromide into the concentration of OH minus. Look at here, not this. Mathematically, rate is directly proportional to the concentration of the methyl bromide as well as concentration of the OH minus. Now, how many molecules, moles are involved here? Substrate is 1 as well as concentration of the hydroxyl ion 1 becomes as a 2, therefore it is a bimolecular, and therefore this rate is equal to taken some constant here, that is a K2 into concentration of CH3 Br into concentration of OH minus, where K2 stand for second order of rate constant, where K2 is equal to second rate K2 is equal to second rate constant. This is a second rate constant, or second rate order second rate constant. K2 is a second rate constant, where involved there are the two species or two moles are participating in this reaction, and we are getting as a formation of the product, and therefore rate is equal to directly proportional to the concentration, means the rate depend upon the concentration of the substrate as well as concentration of the nucleophile, and that's why we are getting these two moles are involved here, and that's why it is called as a bimolecular reaction. Why bimolecular reaction? Understood right now? Two moles are involved here, one with substrate and another for the nucleophile, and therefore it is termed as a second bimolecular reaction. What is this? So this is all about the kinetics. In the kinetic we are finding the rate of reaction. Whether that now let us look at as a second point we are going to learn here. The second point, what is the second point we are going to learn? Second point will be the proposed mechanism. B point is a proposed mechanism. Proposed mechanism. As we know that mechanism is a language of organic chemistry. Now proposed mechanism, who proposed this mechanism? The great scientist Ingold proposed this mechanism, I think in 1925, and that's why that Ingold is a scientist name. He proposed this mechanism. How the mechanism? Now as we know that this blackboard, now this blackboard is a two-dimensional entities. Now you have to visualize the organic molecule normally in a three-dimensional, and therefore there are the four conventional ways to represent the organic molecule on the blackboard. In T.Y.B.Sc we learn the stereochemistry of the organic compound, how to draw. First one is a Weiss or dotted formula, second one is a Sawhorse or Andrun formula, third one is a Newman projection formula, fourth one is a Fisher projection formula. All these formulas have a certain rule. According to that rule you have to draw, you have to visualize the organic molecule. Here the according to as a first rule, Weiss formula or the dotted formula, how to represent that carbon atom. We know that this carbon atom, let us see here Br, and one of the hydrogen atom I am showing here. I am showing these two bonds are the normal bonds according to as a Weiss. So this hydrogen atom, carbon atom, and these Br, bromine atom, they are lying in the same plane, and that's why it is represented by a normal line. Understood? This is the first rule for Weiss formula or dotted formula. Now second one, because we know that carbon is a tetravalent in nature, and therefore one of the hydrogen atom, so this shown by the thick lines, right? This is shown by the thick lines here, or an tetrahedral. So let us see here, or dotted line we have to show here. One bond shown by the dotted line, this hydrogen atom, that clearly indicate that the hydrogen atom which goes away from us, or in short you can remember, that is below the plane, and one of the hydrogen atom which goes above the plane or which is coming toward us, so that is shown by thick line or the solid line. These hydrogen atoms are there, and now this is, as we know that this carbon atom, what type of the hybridization it has? It shows as a sp3 hybridization, tetrahedral geometry. That is tetrahedral geometry. We know that the bond angle. What is the bond angle for tetrahedral geometry? That is a sp. So that is a 109.5 degrees centigrade. And now what is happening here? OH minus now is going to attack on this carbon atom. Look at this carbon atom is electropositive in nature, because this molecule now become as a polar. Why it is a polar? Look at here, carbon atom and bromine atom. As we know that bromine is more electronegative than carbon atom, and therefore bonding pair or the electron density toward bromine atom is a greater, and therefore it gets partial negative charge on the bromine atom. And on the other hand, this carbon atom facing, there is a less number of electron density on it, and that's why it gets the partial positive charge on this carbon atom, and therefore this bond becomes as a polar in nature, means there is a electronegativity difference between these two atoms, and therefore this whole molecule becomes as a polar one. Now the nucleophile attack from the back side, means it approaches from the back side. At the when it approaches, the bond is going to form here, and at the same time bond is going to break here and form the here you can call it as a here you are going to get as a transition state here. HO, then dot carbon atom, then dot Br, then one of the hydrogen atom we can draw like this, and one of the hydrogen atom you can show like this, and one of the dotted line hydrogen atom. Now this step, it is a what we can call it, here is a minus delta charge, here also has a minus delta charge. This is known as a transition state. This state is known as a transition state. This is known as a transition state, right? This is a transition state over here. Now this is a first step, and step number first, and this step number first also known as RDS. RDS means what? Rate determining step. RDS means what? RD is equal to rate determining step. Rate determining step. RDS means rate determining step. Means we can actually measure how much time taken when the nucleophile is attacking over there and form the transition state. This is the transition state. This is a short-lived transition state, and in the second step number second here, step number second is a very fast step. Now the fast step, within a fraction of second reaction takes place, means this transition state collapses into as a product, and we are going to get the product is like this: CO, then C, one of the hydrogen atom as it is, then look at one of the hydrogen atom goes back, and this H like this, just like as you might have as an umbrella in during the high wind. So what type of the condition that umbrella getting, so this type of the thing means we are getting as a inverted configurations are there, right? If you start with the chiral center and then we will give we will see that one. But this is a mechanism of Sn2 mechanism, right? Look at here how the mechanism takes place. This transition state, again this carbon atom has a 5 bond. If you see here 1, 2, 3, but there this HO and Br, they are maximum apart from each other. There is a minimum steric interaction due to the maximum apart from there. There is a what we can call it as a dipole repulsion also as a very less in this case, and that type of the thing is called as a this mechanism. This is a very what we can call it as a Sn2 mechanism. So look at in the Sn2 mechanism what you have to talk, that OH minus means nucleophile is attacking from the backside. Why that attacking from the backside? That third point we are going to look here. Why backside attack? So that is the third point we are going to learn here. C is a why backside attack. Why backside attack? Why backside attack? Why backside attack? That is a question mark here. Why backside attack? That is the third point we are going to discuss here in the Sn2 reaction. Why? If you look at, if you observe this reaction carefully, this mechanism carefully, what do you see there? OH minus is attacking from the backside. Why not the front side? If you imagine OH minus if coming from the front side, what is happening there? The Br which is a nucleophilic in nature, or which having as a negative charge, suppose let it be, or non-bonding electron pair over there, and this nucleophile also living group as well as nucleophile both are negatively charged, and therefore there is a lot of dipole interactions are there, and due to this reason the nucleophile is not attacking from the front side, it is preferred to attack from the backside. Look at, there is a backside hydrogen atom and a hydrogen, all the hydrogen atom in a smaller size. There is a OH, and this carbon atom is a electrophilic in nature, and that's why the nucleophile prefer to attack from the backside only, it not attacking from the front side due to the presence of living group. And when this when does the energy come for? There is a formation of this OH bond is going to form. When the OH bond is going to form, what type of the things are happening? Whether the energy is generated or energy is consumed here. When the OH attacking means there is a formation of the new covalent bond. When the formation of the new covalent bond start forming, there is a release of energy. Release of energy, and whatever energy released during the formation of the reaction, that reaction is called as a endothermic reaction. And when this whatever energy generated over here, this energy is utilized to break the bond between CBr. It is utilized for breaking the bond between, it is pushing leaving group from here, that whatever energy, and then the energy is utilized, means energy is consumed during the breaking of the bond between CBr. Energy is consumed, and this reaction is called as a exothermic reaction. And the proof of why OH minus attacking from the backside, the thermodynamic or the quantum chemistry also proves that the attack of nucleophile from the backside. So this why backside, just now we have seen. I think a remaining point, what is that? Transition state. Then next one is a energy profile diagram or the stereochemistry. This type of the point we will discuss in the next lecture. Let us stop today here. Thank you. Have a nice day.